Watch the center of this disc. You are getting sleepy. No, just kidding. I'm not going to hypnotize you. But are you starting to see colors in the rings? If so, your eyes are playing tricks on you. The disc was only ever black and white. You see, your eyes don't always capture the world as a video camera would. In fact, there are quite a few differences, owing to the anatomy of your eye and the processing that takes place in your brain and its outgrowth, the retina. Let's start with some similarities. Both have lenses to focus light and sensors to capture it. But even those things behave differently. The lens in a camera moves to stay focused on an object hurtling towards it, while the one in your eye responds by changing shape. Most camera lenses are also achromatic, meaning they focus both red and blue light to the same point. Your eye is different. When red light from an object is in focus, the blue light is out of focus. So why don't things look partially out of focus all the time? To answer that question, we first need to look at how your eye and the camera capture light: photoreceptors. The light-sensitive surface in a camera only has one kind of photoreceptor that is evenly distributed throughout the focusing surface. An array of red, green, and blue filters on top of these photoreceptors causes them to respond selectively to long, medium, and short wavelength light. Your eye's retinas, on the other hand, have several types of photoreceptors, usually 3 for normal light conditions, and only 1 type for low light, which is why we're colorblind in the dark. In normal light, unlike the camera, we have no need for a color filter because our photoreceptors already respond selectively to different wavelengths of light. Also, in contrast to a camera, your photoreceptors are unevenly distributed, with no receptors for dim light in the very center. This is why faint stars seem to disappear when you look directly at them. The center also has very few receptors that can detect blue light, which is why you don't notice the blurred blue image from earlier. However, you still perceive blue there because your brain fills it in from context. Also, the edges of our retinas have relatively few receptors for any wavelength light, so our visual acuity and ability to see color falls off rapidly from the center of our vision. There is also an area in our eyes called the blind spot, where there are no photoreceptors of any kind. We don't notice a lack of vision there because, once again, our brain fills in the gaps. In a very real sense, we see with our brains, not our eyes. And because our brains, including the retinas, are so involved in the process, we are susceptible to visual illusions. Here's another illusion caused by the eye itself. Does the center of this image look like it's jittering around? That's because your eye actually jiggles most of the time. If it didn't, your vision would eventually shut down because the nerves on the retina stop responding to a stationary image of constant intensity. And unlike a camera, you briefly stop seeing whenever you make a larger movement with your eyes. That's why you can't see your own eyes shift as you look from one to the other in a mirror. Video cameras can capture details our eyes miss, magnify distant objects, and accurately record what they see. But our eyes are remarkably efficient adaptations, the result of hundreds of millions of years of co-evolution with our brains. And so what if we don't always see the world exactly as it is? There's a certain joy to be found watching stationary leaves waving on an elusive breeze, and maybe even an evolutionary advantage. But that's a lesson for another day.